Hi, this is Chris, and we are taking a look at Test 2, Section 4, questions 12 through 14. So here we'll take a look at question 12, which reads, on January 1st, 2000, there were 175,000 tons of trash in a landfill that had a capacity of 325,000 tons. Each year since then, the amount of trash in the landfill increased, so we want to make sure we note the direction of that change, increased by 7,500 tons. Y represents the time in years after January 1st, 2000. Which of the following inequalities describes the set of years where the landfill is at or above capacity? So at or above tells us that we're going to be looking at an inequality. And we have to see if we can figure out how to come up with an expression representing the current amount of trash. So this gives us a starting value, which will be a constant. There's 175,000 tons initially. So we want 175 to be a constant value that we are then going to add on to with this increasing amount here. And if we look at our answer choices, that's enough right there to pick answer choice D. So we could pick that and move on, but just to make sure that we have some clarity about how the entire inequality comes to be. So this is your constant amount, and then the 7,500y, it's 7,500 tons, and it says that that is each year. So that's why we're multiplying 7,500 times the number of years, which they tell us in the question is y. Y represents the time in years. And then we want it to be at or above capacity. So that's why the inequality here, this inequality that we see of greater than or equal to, this is representative of the at or above phrase, the at or above 325,000 capacity. And so together we have an expression for the amount of trash compared to the capacity for trash, and that inequality matches up with D. All right, let's dive into question 13. And again, this one is going to be one of those questions where we have to understand something conceptually a little bit more than, like anything calculation based. So this is really a concept question. It says a researcher conducted a survey to determine whether people in a certain large town prefer watching sports on television to attending the sporting event. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences of all people in the town? So here we have a sample and we have a population. The population, they're trying to draw a conclusion about the preferences of all people in the town. So this would be our population. The population is all the people in the town. And let's see where we gathered our sample, or how we gathered our sample. So the researcher asked 117 people who visited a local restaurant on a Saturday. So this is our sample. And what we have to look at whenever we're evaluating the reliability of a sample is we have to see if every member of the population had an opportunity to be selected. That will tell us whether or not our sample is reliable. A lot of people think it's about numbers. A lot of people think it's based on sample size compared to population size. And that by itself does not tell us reliability. So of course, we would love for the sample size to be as large as possible. That would make us feel even better. But fundamentally, the reliability comes from looking at the population and determining whether or not every member of that population had a chance of being included in the sample. And in this case, if we're looking for the preferences of the people in a certain large town, if we're looking at just one local restaurant on one day, then the population as a whole did not have a chance of being selected. It was only the individuals who happened to be attending that one restaurant on that one day. So it actually is going to be the location where the survey was given that is the problematic piece of this data collection. So again, just remember that whenever you're looking at sample and testing reliability, here we want to keep in mind that every member of that population should have a chance of being selected in order for that sample to be a valid or reliable sample. Up next, let's move over and take a look at question 14. And here we see a figure which shows miles traveled by air passengers in country X from 1960 to 2005. And we see a bunch of data points here. So those individual points are what we might call a scatter plot, and then this line is a line of best fit, or sometimes referred to as a regression line, which is basically giving us the best approximation of the trend in the data. So you want that best fit line to be as close to each of the data points as possible. And let's see what our question asks. So according to the line of best fit in the scatter plot above, which of the following best approximates the year in which the number of miles traveled by air passengers was estimated to be 550 billion? So let's see where we can find that. They're asking about number of miles traveled. And if we look, we see that that is going to be on our y-axis here. So we can look at 550, which is going to be right here, right in between 500 and 600. So 550, I'll squeeze that in there. And if we follow that line all the way across and see what year that corresponds to, it intersects with our best fit line here. And if we follow that point down on the x-axis, that's somewhere between 2000 and halfway in between 2000 and 2010 would be 2005. So it's somewhere between 2000 and 2005. And you can even tell there that my line was not great. It's a little bit crooked, but that should give us enough information. We're looking for a value between 2000 and 2005. And whenever you have to eyeball something like this and they don't give you an equation where you can calculate it exactly, then they should only have one answer choice that falls in that range. And in fact, that's exactly what we see here. There's only one answer choice C, 2003, that falls in between 2000 and 2005. So that'll be our correct answer for question 14. Thanks for watching, and we'll dive into question 15 in our